the next steps, the first step we are going to do is to configure the Redis key value in memory database for two reasons. The first is to store user profile, and the second reason is to store responses for performance. So whenever we get a response for a particular endpoint, we can store that in Redis key value store, and we can serve any requests from that store rather than actually going back to our MongoDB. The second thing that we like to do is to do user management, and we have already created order, customer, and product entities. So we'll be creating user entity and create related repository, use cases, services, and controller classes. The only difference between other entities and user management entity is that in user use cases, we have login, register, and log out use cases as well. And they depend upon hashing and JWT token generation and some other modules. And finally, we will be setting up our passport.js and middleware that can actually authenticate our endpoints. After securing our routes, we will be testing our application using Postman, and we will be sending in JWT tokens with every request. One thing that I haven't mentioned on these slides is implementing the refresh token strategy or mechanism. So we will have a look at that as well. Now let's revisit our package.json. I have npm installed different packages here. You can look at bcrypt and its types. This is used for hashing our password before storing it to the database. The second one is express rate limiting. And here we have the Redis package that will serve as the client for us. Then JSON web token, and there are few passport.js packages. And here we have the Zord package that is used for the validation. I have created Redis folder under databases and placed redis.ts that contains the Redis client class. It helps us initializing the Redis client. I've imported the ioredis package and then the .env, loading the environment variables, and then I am using those environment variables to initialize my Redis client. Setting up these options here that will be used inside my constructor of Redis. And once I've created the Redis client, I can connect to it, and finally I am exporting Redis client so that I can perform several different operations. Now I like to go to schema. So we are revisiting schema here. I have added user model here to store username, password, and profile related information. After this, I have regenerated my Prisma client to store user related information or to retrieve user related information from MongoDB. And I'll not be going through those steps as we have done that part in part 2. And then I've created the user repository, and just like we have done in part 2, I have created different method for create, read, delete, and update. And here you can see that I have one extra method, find by email. I have a method find by username and find by ID. And find all will find all the users and return a JSON array that we can present to our REST API user. Under use cases, I've created those use cases that are using my repository class, like register use case. Here I am trying to register a new user. When I receive a username and password, I hash my password and then I call the user repository.create and pass it the user, and that will be actually serialized to my MongoDB database. This user delete, which is pretty similar to other delete use cases. And if I go below there, important use cases, and in this use case, I am trying to receive email and password. And based on that email and password, I try to find the user by mail. And once I get the user, I can compare the hashed password with the password I have received. And if it is successful, then the next step is to create a JWT token. So I'm creating two different tokens. One is the JWT token that I'll be sending out with each request if I've authenticated user. And for further security, we have the refresh token. That token will be expired in 1 hour, and whenever we like to refresh our token, we will be using the refresh token to get a new token. And the process is like that we have the JWT token package here, and with JWT token, I'm calling sign and passing in the username and the environment variable. It is a secret that is stored in my .env file, and then I am passing in the expiration time for the token. And once successful, I will get the token that I can send back in my response. And the second thing that I am doing here is that I am calling JWT sign again to generate another token that will serve as a refresh token. And if my token is expired, my API client can send back the refresh token to receive a new token. In the last line of login, I'm also storing my user into Redis in-memory key value database. And I'm sending out or returning token and refresh token back from this use case. And now let's go to the logout use case. Here what I'm trying to do is to delete my user that I'm storing inside Redis. Now we are in the refresh token use case, and here I have created a decoded token that will help me out to extract components of the refresh token. Then I'm setting the 1 hour to 3600 here. Then I'm coming here in the refresh token, and in the execute, I'm receiving a refresh token. And the next step I'm trying to do here is to verify, JWT verify, and then I'm passing in the refresh token, and it will use the secret to verify if it is the token that we have generated, and then store it in a decoded format. In the second step, I am retrieving the stored user ID from the Redis. If I am a successfully logged in user, then I can always find my user profile or the user object in the Redis. So the next step, here I am trying to convert that user string into a JSON format so that I can extract ID from it. And if the user exists, then I can always create a new token. I can prepare the response here to send out back to the calling client. In case it is not working, I will return null that I'll be handling in calling code, and then we have exception handling mechanism here if something unexpected happened during this call. Maybe Redis server is not working or something else is breaking. Now my use cases will be used by my service classes. Our user service class here, which is pretty much similar to the other classes we produced earlier on.
Now let's have a look at user controller that will be using our service classes. It is similar to customer order and product controllers and it is actually trying to produce the final response we like to send out as a result of our HTTP request. We will be wrapping our exception into extended exception and throw it again so that it can be handled by the global error handler we created earlier on. So there are all the use cases here. In case we fail any kind of login, we can always send out unauthorized. So it is time to visit infrastructure authentication.ts that encapsulate the logic for passport.js and setting it up. In the top, I'm importing all the libraries or modules that I need for setting up Passport. That includes Passport, Passport Local, and JWT. Passport is our main framework, and Passport Local and Passport JWT are the two strategies we need at the moment. The Passport Local strategy allow us to authenticate our user using login and password, and Passport JWT strategy allow us to authenticate our tokens that we send in as a bearer token. And then we have user entity and the repository Redis client.env that loads our environment variables from .env file, and the bcrypt that help us encrypting or decrypting our passwords. And in the next step, we are loading .env.config that will load our environment variables into memory and it will make them available. Then in the passport class, passport config, in the constructor, we are calling two methods that set up our local strategy for uh, authenticating user using login and password, and then set up JWT strategy as I explained above, setting up our JWT strategy. And let's visit these two methods here. The first method, we are not using this method in our current arrangement, but we can use it because we have created login user use case and we are directing our route to login controller rather than directing it to the setup local strategy. Both of these places can be used to authenticate user using custom login and password. What I'm doing here is I'm using passport.use and creating a new local strategy and passing in the username and password that I can use to authenticate my user. But I'm not using this function at the moment. So I go below here with the setup JWT strategy, and this particular strategy helped me to validate my tokens that I receive with each request and that I'm using. And for that purpose, how I'm setting it up, I'm calling the passport.use and creating a new JWT strategy object and passing in two parameters. The first parameter contains the token that I received, and I extracted that token using extract JWT from auth header as a bearer. There are several different methods available depending upon how you are sending in your token in your header or anywhere else. In my case, I am sending it in header as a bearer token, so I'm extracting it from the request and passing it to the JWT strategy for validation. The second thing I need for validation is the secret key that I am extracting from .env file. And then as a second parameter, I have an anonymous function here that is executed if my token is validated. And I'm just actually getting back my user from the Redis in this case because my user is already authenticated and my user is using tokens to call different REST endpoints. I expect the user is already in my Redis cache and I'm extracting it. By using JWT payload, which this function is receiving as a result of successful token validation, and I extract the ID and use this ID here to get my user. Then once I receive the user, I can send it back to the calling mechanism In case of any error, I am sending null and false. Null is primarily saying there is no error, but authentication is failed out. Maybe the user is logged out. If I failed to find the cached user, it is clear that user was not logged in. And finally, I'm handling some other errors here, exceptions, and I have another public method here to initialize my passport module. And now I am getting into routes, going to presentation layer. Here, I have different routes available with me, and if you have a close look, then at the top, I'm seeing authenticate JWT and passport.authenticate passing in the parameters, and I'm not using any sessions to store the user information. I want to keep my code stateless. And if I go one step ahead here, if I'm going one step ahead here, then you can see that I am adding this middleware authenticate JWT in each of my route. And I'm leaving out two routes like login and register. Register helped me to create a new user, and login is called by a user that is not yet authenticated. So I am not token authenticating these two routes. And similarly, I've changed all of my other route files like products and orders and customers. In my app.ts, there are a few things I'm doing. This is the object of the class that I just showed in authenticator.ts. I'm creating an object and calling my initialize method to initialize passport.js for authentication.
Input validation is another important aspect of software development. It can be performed at front end or back end both. We are considering input validation at backend at the moment, and for this particular end-to-end series, I am using Zord module, and you can find its documentation on zord.dev, where you can find schema-related details and how you can use it.
So I'm in a validation folder that I created with two files, customer schema and customer validator. I'm implementing validation only for customer. The first file, that is customer schema.ts, I'm importing the Zord that I npm installed earlier on, and then I have customer schema here. I have zstring.min, and in this case, I'm telling that customer schema cannot be null or empty. And similarly, I am also putting a constraint on C email that it should be a valid email address. In case of orders, I am declaring it optional for this schema. If I go to the customer validator, this code allow me to validate my input using this validator. And here I have the class validator. And then I have a method validate that takes customer entity and then apply schema on it. Customer schema parse customer, and if the validation is successful, then it will bypass, or otherwise it will throw an error. We can name that error as customer validation error. Now let's go to the use case, create customer use case. And in this case, I am importing the validator here, validation slash customer validator, and getting customer validator class. And in constructor, I'm creating the object for customer validator. And in execute method, I am validating the customer against the schema that I've provided for Zord. And after that, I'm creating the customer. So this validation method will either throw an exception, or that will be handled by the global error handler, or in case it doesn't send any exception, we will safely create a new customer.
Now it is time to test our application. I have changed Postman environment a bit. I have added token and refresh token environment variables. These variables are automatically updated whenever I log into the system using the login endpoint or I refresh the token by sending in the refresh token. If I go to my collection, you can see that I have already created some endpoints here. Get all users, get user by ID, and login. If I go to the login, you can see that I've added a script that will help me updating global variables based on the response I get after successful authentication. If I go to any endpoint like get user by ID, I am passing in the ID in path variables colon ID headers. If I go to headers, then in headers I have added authorization keyword I, and then bearer in the value and the global variable. There is a space between bearer and the global variable. And I did that for all the endpoints. And now I'm going to log in. Observe it is a post. Now I'm sending a request. It sent back the token. My environment variables are automatically updated by my script. After logging, let's run this. I'm getting the response. And similarly, if I run all users, then I can get all the users. If I get to the customer, get all customers, and I have authorization here in header. I can get all the customers. Now let's try by logging out. I'm logging out here, and now let me try to run the get customers again. Unauthorized, that's what was expected. Similarly, if I go to get all users, it is also unauthorized. Let me log in again. So I'm using the same credentials to log in again. Body with email and password. And now I am logging in again. And if I go back to environment variables, globals, and they are updated. So going back to collection, after logging in again, I am sending get all users. It is working as expected. Now I want to refresh my token. In this case, I have a script again, and once I receive a response, a new token, I will just update token global variable. And I can send in a refresh token rather than token here. And save and send. So sending in the refresh token, I got the new token that is automatically updated in global variables. And I'm calling the get all users again.
Cross-origin requests help us to define domains that are whitelisted for accessing our REST API endpoints. In this course.ts file that I created under presentation middleware security, I am defining options. In origin, I am defining few URLs that are whitelisted to access my endpoint. That includes Prometheus endpoint at localhost colon 3100. And the methods like get, post, put, and delete, all of them are allowed and I'm exporting these options to be used in app.ts. Similarly, if I go to ratelimit.ts, I am using the rate limiter from the express rate limit, and the options help us to define a time slot in which a particular IP address can send X number of requests. In this case, we have rate limit options, and window ms defines the 15-minute slot, and the max defines the maximum number of HTTP requests that can be sent during that 15-minute duration. And if you go to the app.ts, we have already npm installed the required modules in the top, and like cores, and we are importing cores module here, and then we are importing the options we just created in the security folder. And if you go below, we are using both of these middlewares for cores and limiter here. And we are seeing app.use cores and passing in the options we just created to whitelist, and app.use limiter that provide us the window and the number of requests. Rate limiter help us avoiding DDoS attacks.